Hi guys, Jack Joe here, and today we're going to talk about light. Hi guys, Jack Joe here, your classmate friend, and today we're going to talk about 10 things about light that makes it one of the coolest things in the whole universe. Let's go. Okay, before I get to number 1, each one of you should have received one paper with 3 questions on it. So listen close and good luck. Question number 1. What is light? Light is a form of energy that travels in waves. It's made when matter is heated up or gains energy. If it's heated up enough, the extra energy will release as light. The more energy matter has, the shorter the length wave. If matter has a small amount of energy, the wavelength will be longer. This energy is called electromagnetic radiation. So, what is light in simple terms? So simply put, light is a form of energy that we can see. It's a very small part of the electromagnetic spectrum, but our eyes can only see a small part of the spectrum, and we call this the visible spectrum. Question number 2. What is the visible spectrum? So what is the visible spectrum? The visible spectrum is what you and I see as color. And as you can see, it's a very small part of the electromagnetic spectrum. Question 3. What is light actually made out of? Have you ever looked through a window and seen a beam of light? Well, that beam of light is made of zillions and zillions of tiny particles called photons. A photon is what light is made out of. It's the smallest unit of electromagnetism that we can measure. The most famous scientist who ever lived was Albert Einstein. He proved that photons were particles that traveled in waves. Question number 4. What about animals? Okay, so we know that humans can only see a tiny bit of the electromagnetic spectrum. And we call it the visible spectrum. The visible spectrum is what we know as color. But that's just what humans see. Are animals the same way? Some are, but many are not. Bees can actually see ultraviolet light. It helps them locate the nectar that they need to eat. If you could see ultraviolet, then you could see patterns that only bees can see. So snakes like vipers, boas, pythons, they all have holes in their faces called pit organs. What are pit organs? They are used to detect infrared light. Infrared is just under the red wavelength, so that's why they call it infrared. It means under red. Number 5. How fast is light? How fast is light? Fast. Very fast. Light is the fastest thing in the entire universe. It's called the cosmic speed limit. It moves at 186,000 miles per second. This means that light can go around Earth 7.5 times in 1 second. And that is extremely fast. It takes about 8 minutes for light to go from the sun to the earth. That means that the sun is 8 light minutes away. The closest star to our sun is called the Proxima Centauri. It's just over 4 light years away. That means if you were traveling through the speed of light, it'll take you 4 years to get there. Wow. Needless to say, if you could travel at the speed of light, you could get wherever you wanted to go in a jiffy. Number 6, a jiffy. Did you know that a jiffy is actually a unit of time? A jiffy is how long it takes light to travel 1 centimeter, which is about 33 picoseconds. And that is pretty fast. Number 7, sound versus light. A vacuum gets its name by the way it creates suction. We call the suction power a vacuum. Imagine if a giant vacuum sucked out all of the air and particles from this room. That's kind of what it's like in outer space. And that's why you can't breathe in space. That means that there is almost zero matter in space. So what does this mean for sound waves? Sound needs a medium to travel through, like air or water. But since that there is no medium in space, you can't hear any sound. That is why you can't hear anything in space. But wait, light is a wave. So why can light travel through space? For a very long time, we didn't know how light traveled through space. We thought that there was a medium that we didn't discover yet. We called it the ether. It wasn't until a scientist came along. His name was James Maxwell. Maxwell's equations helped us learn how light traveled through space. But that's a little advanced, so we won't worry about that right now. In fact, we should slow down a little bit. Number 8, slow light. Speaking of slowing down, did you know that light can slow down? That's right, we can get light to slow down. When light travels from air to water, it slows down, and that causes it to change direction slightly. This is what we mean by refraction. For example, in water, light moves 3/4 from the speed of light. When light is shined into a prism, that changes the waves. It separates the light into different waves because each wave is moving at a different speed. So when the light leaves the prism, you see all of the colors that make it up. Number 9, transparent, translucent, and opaque. Depending on which wavelength we're talking about, it determines the type of electromagnetism it is. Transparent, translucent, and opaque are 3 important words regarding the nature of light. These 3 words describe how light reacts with everything around it. Transparent objects are objects that light can go through very easily. A window or plastic wrap are good examples of transparent objects. Iceland has bodies of water that you can see straight to the bottom. Have you ever seen an Indian painted glassfish? This is one of many creatures that we can see straight through, just like the glass frog. Translucent objects are objects that light can travel through partially. Good examples are sunglasses, ice cubes, and even stained glass windows. Those are examples of translucent objects. Opaque objects are objects that light cannot travel through, like a door or a soda can. Alright guys, last one. Number 10, how do we see color? We see a color when an object reflects one color from the electromagnetic wavelength, specifically the visible spectrum. Take a look. Green leaves absorb all of the colors and it reflects green. But what about bananas? They absorb all of the colors of light and reflect yellow. White objects reflect all of the colors at the same time, so we see it as white. Black objects absorb all of the colors, so we don't see anything and it looks black. Okay, remember that paper that I gave you? That has 3 questions on it, and that is going to be your homework assignment. Alright guys, thanks for watching. Talk to you soon. Well, actually, I'm saying right there. Never mind.